Okay, good morning, everybody. It is Monday, 11/2. It's the new quarter. So before we start anything, we've been talking about square roots, okay? And I'm going to just do a little quick review because it's been a while. So with square roots, a couple of things. One, we learned how to reduce them. Example is if we had the square root of, say, 75x to the 7th power. Okay, real quick review. We are going to look for perfect squares. So square root of 25, square root of 3. And we do that because the square root of 25 is 5. So we're looking for perfect squares. And we're looking for an even number here. So we take 1 away, x6, square root of x. And we do that. Then what we get, the square root of 25 is 5. So we're reducing. We're just taking numbers out of the square root. 5, and we got to take half the exponent, half our exponent, so we make it x to the third. And so what we've done is taking out perfect squares out of the square root. And what's left are numbers that we can't do anything with, so they stay in. But we've still made it so that we've reduced it. We've taken numbers out of the square root and made it easier, made it better, okay? We've also learned that you can multiply these. For example, we could have let's do a 2 square roots of 3 times a 5 square roots of 6. And we've learned that you can multiply whole numbers with whole numbers and square root numbers with square root numbers. And then if you can go further, which in this case you can take the square root of 18, which is going to be, well, let's see, we can take out a perfect, we're looking for perfect squares like the square root of 9 times square root of 2, because 9 times 2 makes 18, but we have a perfect square. And then we can do that, we can reduce that to 10 times square root of 9 is 3, square root of 2. Okay, now that's a whole number. When it's a whole number, you can multiply whole numbers. And you get 30 square root of 2, okay? And then since you can't take the square root of 2, it's an ugly irrational. That's the word I want you to remember, irrational. If you go square root of 2, it's an ugly irrational number. It's a number that just goes on forever and ever and ever and never ends, never repeats. So we leave it like that. And then finally, we learned about adding square roots or subtracting. If you had a 3 square roots of 2 plus a 5 square roots of 2 minus a 6 square roots of 3, you can add these two. These two you can add, but you can't add that because that's different. It's different. So you get a 8 square roots of 2 minus 6 square roots of 3. Now, there are times when you don't know if you can add them. For example, we do up here real quickly. If I have a square root of 18 plus a square root of 50. At first, you're like, you can't add those. They're different, Mr. Davies. But what if we can reduce these? And this one you can. We know we just did it over here. Square root of 18 could be 9 times 2. And we can also break down the 50 into 25 times the square root of 2. So you can find perfect squares. Perfect squares is multiple. 9 and 25 are perfect squares because we know the square root of 9 is 3. And we know the square root of 25 is 5, and then you can add them. Okay. Now, what about today? Well, today we're going to talk about division. So division is easy if they are perfect squares. Example, if I had the square root of 16 over 25, easy, 4/5 because the square root of 16 and the square root of 25, right? But today's lesson has to do with ones like this. So what's our objective today is going to be rationalizing denominators of roots, okay? This is square root of 5. It is an irrational number. We want to rationalize it. This is an irrational number. So what we do is this. Write this down. We fix the problem with the problem. What? What are you talking about? We fix the problem with the problem. Well, I'll show you. I'm going to show you how this works. Okay? So, if the problem is the square at the bottom, so you can't have a root in the denominator. We'll say the bottom for you, okay? But it's called the denominator. If you can't you got to get rid of the square root of 5. So how do you get rid of the square root of 5? You fix the problem with the problem. So how do you get rid of the square root of 5? You multiply by the square root of 5. Check this out. I'll show you why that works. So you fix the problem with the problem. Now you have to multiply top and bottom because you've multiplied by 1. Okay, the problem is the square root of 5. You can't have a square root of 5 on the bottom. You can't. That's the rule. You can't have a square root on the bottom. So how do you fix it? Multiply top and bottom by the problem. You have to do both. So what happens is you get 3 square roots of 5 on the top in the numerator, whole number, irrational number, so you can't multiply. But this, you get the square root of 5 times square root of 5, you get the square root of 25, right? Square root of 5 times square root of 5, square root of 25. And then, whoa, hey, wait a minute, you can take the square root of 25, can't you? Because that's a perfect square. So what you've done is you've created a perfect square, which is 5. On the top you have 3 square roots of 5. Now, don't divide these. Don't divide these because this is really not 5. Don't divide. That's your answer. That's your answer. Don't divide those because square root of 5, hold on, square root of 5 is really not a nice number at all. So don't divide those. That is your answer. So what have you done? Well, you've taken it and you made sure that there is not a square root in the bottom. Okay? Example 7. Example 2 is same thing. So I'm going to rewrite this one as the square root of 5 over the square root of 7. Okay? Again, how are you going to do this? Well, you fix the problem with the problem. You can't have a square root on the bottom. So I'm going to multiply by the problem. Okay? Here's the trick. You can't have a square root on the bottom. How are you going to fix that? You fix the problem with the problem. So you multiply top and bottom by the square root of 7 over the square root of 7. That's how we do it. Okay? Now, you can multiply those two. You can get the square root of 35 over, you can multiply the square root of 49, okay, 7 times 7. But the square root of 49 is a perfect square, so the square root of 49 is just plain old 7. So you get the square root of 35 over 7. Don't divide those because that's not really a 35. It's an ugly square root. Square root of 35. Don't divide those because the square root of 35 is really a bad number. Yeah, see, you wouldn't want to divide those at all because that's just really an ugly number. So that's your answer. We'll skip this one because it's exactly like 1. If you guys want to do that one on your own. Example 4 is kind of unique because of the 4. Example 4 is kind of easy. You know the square root of 4 is 2, so it takes care of itself. Okay, done. It's done because you don't have a square root in the bottom. Now, example 5. This one is different. It's going to take some work. So, you have to multiply because of the negative here. And I've got one on the back too that shows it as a positive, okay? That if you get 2 terms on the bottom, you have to multiply by a thing called the conjugate, which is like the opposite. Let me show you. You're going to multiply by, you ready? You're going to multiply by 7 plus the square root of 3. Okay? Multiply top and bottom by 7 plus square root of 3. That's the conjugate. It's a plus minus thing. It's a plus minus thing. Okay? Let me turn the page. Okay? On the back side, again, I'm going to come back to that. I'm going to come back to that one. We would multiply by the conjugate. We'd multiply by 2 square roots of 3 minus 3 square roots of 5. Top and bottom. Okay? So let me go back to the one I just looked at. So we're going to multiply by the opposite. See the plus? Notice, how does that work? Let me show you how it works. So here, if I multiply this, I've got to distribute this times this times this. So on the top, the numerator, you're going to get 35 plus 5 square roots of 3. And in the denominator, we have to FOIL. We have to FOIL, okay? Are you ready? I'm going to do this slowly. 7 times 7 is 49. 7 times 3 is a positive 7 square roots of 3. Negative square root of 3 times 7 is a negative 7 square roots of 3. And negative square root of 3 times negative square root of 3 is a negative square root of 9. Okay, now here's what happens. These two cancel. Right? I like that. And this is a perfect square. Oh, look what's going to happen. So on top, we'll leave that. We'll just leave it 35 because we don't mind if there's a square root in the numerator. Okay, square root in the numerator is okay, but in the bottom, the denominator, you've got a 49. That's gone. That's gone. Minus 3, right? Square root of 9 is 3. 49 is 3 is just plain old 46, right? And you got a 35 plus 5 square root of 3. 46. Now let's see what we did. What's the rule? What's the rule? Let's go back. What's the rule? Can't have a square root in the bottom or in the denominator. And we don't. Okay? So now, if we scoot back to example 8, we've got the same thing. But let's do 6 and 7 first. We'll come back to 8, okay? So first of all, in 6, we're going to do this one last. I'm going to have a square root of 3 over the square root of 50, okay? So in example 6, I'm going to rewrite it as 2 separate square roots. Now, I can probably do a little bit of work with the 50. Before I do a whole lot, let's try and reduce the 50 before we multiply the by instead. Golly, it's early. So instead of multiplying by the square root of 50, square root of 50, let's reduce the 50. So let's go ahead and rewrite this as square root of 3 over. I know there's a perfect square. 25 and 2. And by doing that, I can make this problem better because I can take the square root of 25 as 5. All right, let's see what I have. I've got the square root of 3 as the denominator, and on the bottom, I've got 5 square root of 2, okay? Now, remember, we are going to fix the problem with the problem, okay? So this problem is the square root of 2. It really is, so I'm going to multiply by the square root of 2, square root of 2. We fix the problem with the problem. We wind up with a square root of 6 over 5 times the square root of 4. Okay, the square root of 4 is 2. Wind up with a square root of 6 over 10. Wow. Okay, there's no longer a square root in the bottom. It's been reduced. It's a much better version, okay? 7 is the same thing except we just have an x. We're going to multiply top and bottom by square root of 3x, square root of 3x, okay? Fix the problem with the problem. You can't have a square in the bottom. So, again, fix the problem with the problem. So I'm going to get a 5 square root of 3x on top because you can't multiply. That's a whole number, and that's a square root. That's a whole number, so you can't multiply. But here you can because they're both square roots, so you get 3 times 3 is 9. X times x is x squared. Okay? This gets pretty easy at this point. Square root of 9 I know is plain old 3. Take half, remember half the exponent, I can do that. I get plain old x. And on top I just get 5 square roots of 3x. Don't divide these because that is not really a 3. That's a 1.73 and that's only half an x. So there's your answer. Now let's get back to this one. Okay? We're going to rationalize, okay? But you can't because of the plus. So you can't multiply the top and bottom. So you have to do the conjugate. This one has to be the conjugate. Okay? If it's a plus or minus, you've got to multiply by the conjugate. Okay, so let's see how this works. So multiplied by the opposite. 2 square root of 3 minus 3 square root of 5. Okay, so let's multiply. In the top, or in the numerator, I'm going to get whole number to whole number. 10 square root of 3 minus whole number to whole number. 15 square root of 5. A square root comes along with it. And in the denominator, I'm going to FOIL. That times that. 2 whole number to whole number. 4 square root of 9. Square root to square root. I'm going to multiply the outside. I get whole number to whole number. I get negative 6 square root of 15 because I get 3 times the 5. Then on the inside, I'll get a positive. Well, whole number to whole number 6 square root of 15 because 5 times 3. And then finally, the last, I'll get the negative 9 square root of 25. Okay, I'm getting there. Almost done. Okay, on the top, in the numerator, can't do anything with it. And we don't mind square roots in the top. We do not mind square roots in the top. So 10 square root of 3 minus 15 square root of 5 over. Oh, wait a minute. Yeah, I like that. That cancels with that. It's supposed to happen. And the square root of 25. Oh, I can do that. That's just plain old 5 also, isn't it? So let's see what. Oh, wait, there's more. Square root of 9 is 3. Look at that. All sorts of things disappeared. Well, 4 times 3 is 12, right? That's gone because these two cancel each other out. Minus 9 times 5 is 45. 12 minus 45 has got to be a negative 33, which is no longer a square root. And on the top, the numerator, I get 10 square roots of 3 minus 15 square roots of 5. And that is what I have for a lesson. There are no square roots on the bottom. Check it out. Okay, finally, I'm almost done. Okay. No, can't have a square at the bottom. I fixed it. No squares on 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 the bottom. I fixed it. No squares in the denominator. I fixed it. Okay. And there's a little assignment in your journal today.